Welcome to Digital VLSI Design Virtual Lab. Experiment number 3, Ring Oscillator. The aim of this experiment is to plot the output characteristics of a 3 inverter as well as 5 inverter ring oscillator. Now to start, click on the Simulator tab. The first link corresponds to a 3 inverter ring oscillator and the second one corresponds to a 5 inverter ring oscillator. Now to start, click on the link. In this new page, on the left top you have the schematics of the circuit setup, which consists of 3 input inverter stages, the first one, second one and the third one. The output of the first stage is connected to the input of the second stage, and the output of the second stage is connected to the input of the third stage, and the output of the third stage is connected as the input to the first stage. Each inverter consists of a PMOS device and an NMOS device. All the devices are labeled as shown in the program. MP1 stands for the PMOS device for the first stage, and MN1 is the label for the NMOS device in the first stage, and similarly MP2, MN2, MP3 and MN3. A voltage supply with label V1 is connected between node N1 and node 0 as the DC power source. Spice level 49 model for NMOS and PMOS device is defined then. Finally, the program ends with a transient analysis to plot the output characteristics for 50 nanosecond, wherein 0.1 nanosecond is the sampling rate. In order to simulate, click on the Simulate tab. The output voltages of the 3 inverter stages, namely the first, second and the third inverters, are plotted with respect to time. Different legends are used to distinguish between the 3 output curves. The output stage of the first inverter is denoted by dashed curves. The output stage of the second inverter, the voltage at node N3, is denoted by dotted curves, and the output of the third inverter stage is denoted by dash dotted curves. It will take a while for the oscillation to build up, and in this case the maximum swing of oscillation starts at around 30 nanosecond. It can also be noticed from the output characteristic curve that the output voltages of successive inverter stages differ by 120-degree phase difference. Similarly, we can go back to the Simulate tab and click on the second link in order to plot the output characteristic curve of a 5 inverter ring oscillator. The only difference here is that we have 2 extra stages, and similarly there will be 2 more curves in the output characteristics corresponding to the 4th and the 5th stages. Notice here the phase difference is 2 pi by 5 between 2 outputs of the successive stages. One also has the option to change the length and width of each NMOS and PMOS device and see how it affects the delay characteristics of the output curves. One can also study how the frequency of the ring oscillator changes as we add more number of stages by comparing the 5 ring oscillator with 3 ring oscillator output. Thank you.